Hi and welcome to a very brief video on how to draw graphs using the gradient and the y-intercept. We're going to look here at two examples, but before we actually get into those examples, I thought it might be an idea just to refresh our understanding of what the gradients refer to. So I'm using the ruler here just as an indication of what a straight line might look at, and we'll focus just on that top or leading edge. So here I'm demonstrating a positive gradient, that is from left to right. My ruler, my straight edge, is going uphill. So any of these values or any of these slopes would actually be indicating that we've got a positive gradient. Now if I was to shift my ruler around here, I've got a negative gradient. You might notice that it doesn't matter if I put my gradient here or here. If they are parallel, they will have the same gradient. Okay, so basically parallel lines are lines which have the same gradient, and we can see that this one is a negative. Anything that slopes from left to right going downhill is referred to as a negative gradient. So all of these ones that I'm currently demonstrating are negative gradients, even something as big as steep as that. And that would show a decrease or a decline in what's happening in your linear relationship. The next one is if our ruler is horizontal. So not surprisingly, if these are positive gradients and these are negative gradients, the one in between, where we go horizontal, the gradient's actually 0. So this line, even this line down here, where my straight edge is horizontal, indicates a gradient of 0. And finally, we have an undefined gradient if our line, our straight line, is actually vertical, and we refer to that as undefined. Okay, so how does that help us with drawing graphs? Well, we're going to look at those two examples, and the first one will be y equals 3x plus 1. Now, to start out with this, I'd suggest that you actually determine what the gradient is, which typically is referred to as m. Gradient is always going to be the number that's in front of the x term. So in this case, that's a 3, so our gradient is 3 and it's positive. So going back to our ruler, that means that we're going to have a line that looks something like that. Now, one thing I should have mentioned is if we've got a diagonal line, and I'm showing a diagonal line at present, that's got a gradient of 1. If it's going downhill and it's diagonal at 45 degrees, that gradient is -1. So here, if our gradient is 1, a gradient of 3 would look something somewhat steeper. Okay, so we actually can pull it up there. We don't have to be absolutely perfect at this point, but just understanding that we're going to have something in excess of 45 degrees. Now the next thing that we've got to do is identify the y-intercept. So our y-intercept in this instance is going to be this number here. It's the number independent of x, so x is not associated with it. In this case it's 1. Now this is the easiest point on the graph to locate, and I suggest once you've identified the y-intercept, you just put a dot on the y-axis, because this is where your graph is actually going to intercept or cut the y-axis, hence the name, the y-intercept. So our point 1 there reflects that our y-intercept is in fact 1. So our gradient, our line will pass through this point and have a slope approximating something like this. But how do we actually work out exactly where it goes? Well, every straight line really requires 2 points to join between. So we've got 1 point and we need to find a second. So we'll do that by just saying let x equal the value of 1. Okay, and so this is it, this process here, we're starting out by actually finding a second point. And then we go back to our equation, which relates, and it says y, the value of y is going to be 3 times the value of any x plus 1 more. Well, if we've just let x equal 1, we can actually say, well, that'll be 3 lots of 1 plus 1 is going to be 4. So that second point that we're after is going to be 1 and 4. So when x equals 1, the corresponding y value is 4. And that's going to be our second point that we require, which will be 1 across and 4 up, and we can mark that in. Now it becomes as simple as joining those two lines and extending it beyond them and putting arrows at the end. Additionally, if I could get you to label the graph, that makes it very clear what it is. So our graph there, just in summary, passes through the point 1, the y-intercept is 1, and has a gradient of 3. Ideally, you actually identify and label an additional point, often when you've let x equals 1. Now, I'll do very quickly another one, this time with a negative gradient. So in this instance, gradient is -2. Remember, that means that we're going to have a downhill slope, slightly deeper than or steeper than a 45-degree line would give us. The y-intercept, which is c, is going to equal 6 in this case. Now notice here that even though we've changed the order of the terms, the gradient is always the number which falls before the x. The y-intercept is always the number without any x related to it. And then the next step is we're going to let x equals 1 again and substitute that value of 1 into our original equation. So 6 take 2 lots of x, remembering that x is now equaling 1. So that'll be 6 take 2 is 4. And interestingly enough, and this doesn't always happen, but interestingly enough, that additional point where x is 1, y equals 4. So we're going to have that same point here, but this time the y-intercept tells us that we've got the y-axis being intercepted there, and we're going to have our line passing through here. Okay, so again, let's label that y equals 6 minus 2x. We can see our two graphs intersecting at this point, quite coincidentally by the way, of 1, 4. A reminder please, could you make sure arrows and y-intercepts are labelled, and similarly arrows and the x-intercepts are labelled too. Thanks very much for listening.